Over the past thousands of years, many contagious diseases have swept the globe. Throughout history, massive pandemics have caused the deaths of tens of millions, wiping out or ravaging civilizations. The plague, cholera, smallpox, diphtheria were able to decimate humans for hundreds of years. In 1918 and 19, the influenza pandemic known as the Spanish flu killed 5% of the world's population in just 2 years. More than died in the entire First World War. Often the immune system is unable to quickly and effectively combat the pathogens of infectious diseases. But once the body has fought off the disease, it usually forms a lasting protection against it. Of course, first, one has to survive being infected. Fortunately, today we can acquire long-term protection virtually risk-free against numerous infectious diseases. Since the end of the 18th century, we have been able to develop increasingly effective vaccines that have helped to virtually eradicate many previously highly deadly infectious diseases. As pathogens work and cause illness in different ways, the types of vaccines against them and how they work are also different. There are several different types of traditional vaccines. Vaccine with a weak or weakened pathogen. In this case, the vaccines deliver naturally weak or artificially weakened pathogens inside an organism. These cannot cause illness, but are able to reproduce inside the body, thus activating our immune response through a process similar to a natural infection. The weak pathogen is identified and easily eliminated by immune cells. The memory cells store this knowledge, and the next time our body encounters a strong pathogen, we will be able to react much stronger and more quickly. These vaccines mostly provide longer-term protection, in some cases, even for a complete lifetime, unless the pathogen mutates very quickly. Vaccine with an inactivated or killed pathogen. These types of vaccines contain a pathogen, or a smaller part of it, that has been inactivated or killed through a chemical process. Although the pathogen cannot divide inside the organism, it can still evoke a similar immune response than the previous vaccine type, and do so even more safely. However, the protection they provide is not as strong, therefore necessitating additional booster shots. Vaccine with antibodies. There are certain types of vaccines where a reaction is needed to pathogens already inside an organism. In this case, complete antibodies characteristic of the disease are delivered with the vaccine. Its great advantage is that it does not require the multiplication of viruses, so it can be produced relatively quickly. But its drawback is that it provides protection only for a short time, until the antibodies leave the organism. 10 to 15 years ago, new types of vaccines based on the genetic material of cells also started appearing. As science advances, these can be developed and mass-produced much more quickly than before against new pathogens. Viral vector vaccine. Viral vector vaccines do not contain a weakened pathogen, or some part of it, only an encoded blueprint of an important part of the pathogen, called an antigen. This blueprint is delivered into the body by a safe, harmless virus. The encoded blueprint is contained in the genetic material, the DNA or RNA of the viral messenger, or vector, which is hacked by scientists. The reprogrammed code induces our body to produce only a small part of the virus causing the disease in question. In the case of the novel coronavirus, the spike protein that evokes an immune response. It is important that neither the viral vector itself nor the small part of the target virus can reproduce or cause illness. So the reprogrammed viral vector orders the cells in our body to produce the protein pattern based on the code, after which it disintegrates. Based on the commands, our own cells themselves produce the antigen that is unable to cause illness, which however evokes a defense response from the immune system, and production of the antibodies begins, followed by the activation of T cells and the formation of memory cells. Thus, the immune system will be able to quickly and efficiently stop an attack later by the contagious complete virus. RNA or DNA-based vaccine. These vaccines work on a similar principle as viral vector vaccines, but in this case there is no transport virus. The encoded blueprint is contained with a nucleic acid molecule constructed for this purpose, which is delivered into the body in a package that can easily penetrate the cell membrane. The nucleic acid molecule is mostly the messenger RNA molecule, but DNA-based coding is also possible. This code, when delivered into the organism, also commands our cells to mass produce the given protein. Neither the nucleic acid itself nor the produced proteins can otherwise affect the normal function of cells. The produced proteins cannot cause illness by themselves, but function as antigens, thus provoking an immune response, antibody protection, the activation of T cells, and the development of immune memory. Once a vaccine is developed and is proved effective against the target disease, for our safety, they must go through multi-step clinical testing phases in order to rule out possible severe side effects and confirm their efficacy. Only after that can the vaccine be mass-produced and distributed widely. 3 different types of vaccines are available against the pathogen that causes COVID-19. All 3 technologies provide efficient protection against the pathogen, thus helping to reduce the spread of the disease.
Subscribe to our channel. Don't miss out on any new episodes.